Welcome to NIOS live classes. Subject Science and Technology. Class 10th. Book number 212. Module number 2. Matter in our surroundings. Lesson 13. Work and Energy. Part 2. In part 1 of this lesson, we have learned what's the meaning of work and the conditions required for work to be done, and types of work, which is 3 types: positive, negative and zero work. And also we have seen the examples of work in our daily life, and also some situations where no work is done. Let's start our part 2, but before starting, let's learn some difficult words for better understanding. First is force. Force, it means a push or pull something. Next is displacement. It means moving from one place to another in a direction. Energy. Energy is the ability to do work. For example, if we have energy, we can do work. If not, we can't do anything or feel tired. Next is direction of force. The way in which force is applied. For example, in first picture, there were 2 boys. One is pulling and other is pushing the carrot. And in this, force applied in the same direction. In second picture, there are also 2 men who are pushing a box but opposite direction. Next is sideways. It means moving to the side but not forward or backward. Next is contribute. To take part or help in something. Next is gravity. Gravity is kind of force that pulls things towards the earth. For example, satellite rotating around the earth because of gravitational force. Next is SI unit. SI means standard unit. It is used in science to calculate something. In simple words, SI units are common measurement units that scientists all over the world use. So everyone understands the same thing at once. For example, there are some things, some physical things and their SI observation. Like scale, its base unit is meter and its SI observation is M. And third, there is a bag, a jute bag. Its base unit is kilogram and SI observation is kg, etc. Next is joule. In short, we can call it J. It means the unit of work or energy. For example, if you push something lightly and it moves, you are using energy and that energy is measured in joules. Next is Newton. Newton is the SI unit of force. In simple words, we can say a Newton tells us how strong a push or pull is. For example, when you push a box or pull a bag, you are using force and that force is measured in newtons. Next is meter. Meter is the unit of distance. In simple words, a meter is used to measure how far something is or how long something is. For example, on a red light, every vehicle pulls a brake, so there is a distance between a car and bicycle is 1.5 meter. Now we have completed our difficult words, so let's begin our part 2 and their objectives are: in this part you will be able to understand relation between work, force and displacement. You can calculate the work done by a constant force and can understand and define energy and its SI unit. And along with it, you can also learn to calculate the work done by a constant force. (13.2) Relation between work, force and displacement. What is work? Work is done when a force causes an object to move or what is force? Force is a push or pull acting on an object. And third is displacement. It is the distance an object moves in a specific direction. Work is found by multiplying the force applied and the distance moved in the same direction as the force. In short, we can say that force is equals to push or pull and displacement is equal to movement in a direction. And how we can calculate the work? We can calculate it by multiplying force and displacement. Let's take a short break. Welcome back to our classes. Now there is a condition where work done is 0, which is if there is no movement, then no work has been done. And the work's formula is force into displacement. Displacement, it means in the direction of force. In short, we can write it down W equals to F into S. S denotes to displacement here. When force and displacement are in the same direction, work is found by simply multiplying them. For example, there is a boy pushing a box, so the force he is using and the distance the box moved combined through we get the work. When force and displacement are in different directions, work is calculated using only the part of displacement in the direction of the force. There is a graphical representation of that statement. For example, if you pull a bag forward, but it moves a little sideways also, then only the forward movement counts for work, the same direction as force, and sideway movements does not contribute in work. Work done here, work done is W equals to F into PR and not F into PQ, because work has been calculated by the force and displacement, and here is force is applying upwards. There is also other example. A person carrying a heavy load on the head and walking on a flat road does no work against gravity. This is because gravity acts downward while the person moves horizontally. So there is no movement in the direction of the gravity. The SI unit of work is joule, in short it is J, or Newton meter, in short it is Nm. 1 joule of work is done when a force of 1 Newton moves an object 1 meter in the direction of the force. (13.3) Energy and its relation with work. What is energy? Like picking up something, walking, sleeping. What is energy? Basically, energy is the ability to do work. It means the power to do work or anything. If you have energy, you can do work. Any work like eating, reading, walking. But if there is no energy, then no work can be done without energy. If a body has energy, it can apply force and cause movement. Without energy, no work can be done. For example, after eating food, we get the energy and the ability so we can walk, talk, play, etc. Simple examples are like a moving ball has energy. So it can hit something and move it from their place, just like a bowling pit. And we also study that food gives your body energy, so you can walk, run, lift things, etc. Work is done when a force causes displacement. Imagine when you play or work for a long time. And after that, after reaching home, you feel tired and hungry. Then you eat something and take some rest, and after that you feel ready to do or work again. So this is the power of energy. This happens because doing work uses energy. To do more work, the body needs more energy. And we have learned that energy is the ability of a body to do work. So at conclusion, we can conclude that without energy, no work can be done. Let's take a short break. Welcome back to Now we will learn the relationship between the work and energy. When work is done, energy is transferred from one object to another. The amount of work done is equals to the amount of energy transferred. We can say that energy of a body is equals to the total work it can do, and the energy unit is the same as work, which is joule. All energy cannot always be fully changed into work. During energy conservation, some energy is lost or wasted. For example, an electric bulb. When electrical energy is converted into light energy, not all energy becomes light. Some energy is lost as heat, which is why the bulb becomes warm. For example, there is a visual explanation of that example, which shows there is electrical energy and light energy. Another example is car engine. Fuel energy is converted into motion, but lot of energy is wasted as heat and sound. There is a visual representation of that example. Fuel energy is an input representing chemical energy, and heat energy and sound energy is output. Now we'll do some activity so we can understand it more better. Activity 13.1. There are two boys, Alok and Kapil. They are filling long balloons in two different ways. Alok blows air into the balloon using only part of the opening. While Kapil blows air using the whole opening of the balloon. Now there is a question put up that which of them is making more effort and which of them is doing more work. After analyzing, we get the answer that Alok is making more effort because he is blowing air through a small part of the opening, which is harder. And Kapil blows air using the whole opening, so he is doing more work rather than him, and his balloon filled faster with more air. Do this activity and find out which technique resulted in a bigger balloon. Can you explain the reason? After self-realization, we get that couple's balloon become bigger because air enters easily through the full opening, so more air goes inside. Because when air goes in easily, it contains less energy. So there is less energy is wasted and more work is done. Same as that activity, we can also conclude that now you can understand why air is blown from a distance in Fukini. Fukini is a metal pipe which is used to burn the fire to cook the food, and it is used for the chulhas in the villages. But here is a precaution note that this cooking practice using Fukini is unhealthy as it can lead to several health related problems. It has been used previously, but now it has changed with the stoves and gas. We have completed our part 2. Thank you for watching.